Hello, everybody. We are going to talk about public GISs and open GIS or open data in today's talk. Today's session is really a lot of exploration on your part and very little lecture on my part. And you'll see that the assignment that's associated with this week is to use a public GIS to find out information about the city of Cleveland with respect to crime analysis, but being able to use a public GIS, navigate some of those different tools and buttons, and to give you some experience with, hey, maybe you don't need to create a brand new GIS project and create something from scratch. Maybe you can find information that you're looking for in some of the public GISs that are available to you or available to the public. So let's talk about OpenGIS and publicly available spatial data and systems. On to presentation mode here. Okay, so OpenGIS data. So you can find a whole lot of open data online, in particular, open spatial data. It's available. There's typically a metropolitan GIS in every major city in the United States. Also, GISs in other countries may not be publicly available in other countries, but within the US, you'll find that most metropolitan areas have some sort of public GIS portal where you can access data. You don't have to create your own specific GIS project, but you can use the software and the open freeware that's available through municipal government and other sources. Open data is typically public data. That means it's regulated by governmental, nonprofit, educational, or other institutions. Somebody was responsible for collecting it or creating it and is making it available to people to be able to do their own research and pique their own interest with spatial data and opportunities to analyze that information. Proprietary data is at cost. That means that a business will charge you for it. That's different than open or public GISs. Those are free and publicly available. You don't have to pay for it. But there are options. So if you can't find it publicly, you can find it at cost. These are typically specific data points, such as for marketing purposes. Proprietary data should be anonymized, so personal data is not revealed, in particular, the privacy aspect of addresses. So the example I give here is addresses of people who have purchased a specific product. Information is typically aggregated, meaning it's not available at the individual address level or household level, but rather part of a larger geographic unit, like a block or a neighborhood or a city or a zip code or something like that. Typically, you should not be able to purchase personal information like addresses of people that are consumers. Some data is private and are sensitive, though, and unavailable for public distribution. Some of those in particular that I've had experience with are water and sewer, electrical, and other types of utilities like cable lines, Wi-Fi portals, things like that. I used to work in a stormwater management division in county planning down in the Cincinnati area, and I worked with stormwater in particular, and that data was private. We could not release or put through the publicly available GIS. When I was a GIS manager there, we were not allowed to make stormwater pipes available for public consumption. Those would typically be private information, mostly for security or safety reasons. We don't want just anybody being able to get to a pipe, knowing where it is, where some of those inlets are, for, unfortunately nefarious purposes. So that you will find that some data is private and is really hard to get. The stormwater or the sewer example, of course, that's managed through usually a quasi-governmental agency, meaning there is a public aspect to that agency, like sewer treatment, for example, but there could also be private companies that are contracted to do some work. Electrical utilities are private institutions, but regulated by the government. Same with cable, for example, as another utility. So I will tell you, it is pretty difficult to obtain information on electrical utilities, in particular, it's just really hard to get it. You have to know somebody to be able to know somebody to be able to access that information. But again, it's also good that some of this information isn't publicly available, and you do have to go through some pretty specific channels to get them. So I just wanted to give you a little heads up on some of the stuff that's not so easy to find and are really a matter of the organization rather than is the data there. So tips for you there. OpenGIS data standards. So there's an organization called the Open Geospatial Consortium, known as the OGC. And it's an international consortium of businesses, government agencies, research organizations, and universities driven to make geospatial information and services fair. FAIR is an acronym for findable, accessible, interoperable, and reusable. That is an open data standard. Being able to create a level playing field in terms of equity to spatial information. And they create and manage royalty-free, publicly available open geospatial standards, meaning, if you are going to compare or use spatial data from lots of different sources, you want there to be some sort of standard as to some minimum requirements for what you receive with that data. For example, who created the data, what date the data is associated with, like last updated or originally created, who is the contact person or contact agency for certain kinds of spatial data. So again, having an international standard is particularly helpful in the spatial data world. And you can look more, at the OGC website to find out more about some of those standards. Onto types of public GISs. And so again, the goal of a public GIS is to provide free, accurate data as it relates to a place. Kind of an interesting anecdote related to that is every public GIS has a disclaimer. And the disclaimer is that even though we're providing this data to you as a free service, it's really up to you to figure out if it's accurate. Which is kind of a strange position to be in, right? You're going to a public GIS to be able to access some spatial data, but you receive a disclaimer on the download or the use as to, hey, you need to verify that this is correct. So again, that's anecdotal, but you will find that most public GISs have some sort of disclaimer saying that, the data that was used can't be used in court or something like that, and that the provider of the data is, even though they may be the authority on the data, they can't guarantee its accuracy in certain time instances. So generally the data is accurate, it's up to date, but you may find some cases in which maybe parcel data has been updated, maybe a water line has been added for a new development, maybe satellite imagery data is a bit outdated, something like that. So know that there's typically a disclaimer, but really that's what you're up against when you're accessing public GIS data. It's a certain degree of confidence, but again, the disclaimer of, hey, you have to verify this to make sure it's correct. Often public GISs include prepared maps, interactive map viewers, in addition to open data downloads. That means that they provide an interactive map viewer like a Google Street View, some sort of GIS software that's operating through the web and provided to you through the web as a map viewer, so that you can use their project, their software, free of charge to be able to find things that you're looking for. A lot of times you'll find maps are also available, and those can be through different departments or different agencies, but it's a cursory Google search of, hey, I'm looking for a map on, let's be timely here, COVID cases in Cuyahoga County. That there are probably maps that are already prepared with that data available to the public through like the Board of Health, maybe some school districts, depending on, if you have as a optional source. But that's again, kind of a tip of, sometimes you don't have to create something from scratch. GIS has been around long enough where lots of people have done lots of research, and it's just a matter of knowing where to look for some of those things. But Google is your help, right? I didn't have Google when I was in school, in college, so take advantage of that. Map viewers are typically limited to just the data sets they're providing. And what that means is that the map viewer or the GIS viewer that you're using to look at the information that's available, that you can't upload or merge it with other GIS viewers. And so there's a limitation, is that public GIS viewers are typically focused on whatever the discipline or field in which the data is related to. So if you are looking at data in different places in Cleveland, for example, you'll find information about parcels in Cleveland. You can find information about roads, you can find information about buildings, but you're not going to be able to find information about water lines. You know, and the example that I gave is that particular utility is private or hard to find. And so you're limited to the focus of each of those viewers, like what's the purpose of the viewer, who's using it, why are you using it, things like that. So asking those questions. And map viewers come in a variety of platforms, but the platform used to create a view are created with a GIS and then provided in the web-based interactive format. So as a GIS technician or a GIS analyst or a GIS staff member or somebody with GIS skills within a particular department or organization, that the platforms vary. And so I say that because all GISs look a little bit the same, but they also look a little bit different. But typically there are some fundamental functions that are built in for you to be able to use and get used to. And so again, it's like the idea of using a software platform. What does the graphical user interface look like? Does it look the same in LA's county GIS than Cuyahoga County's GIS? How old is the software platform being viewed in terms of is it up to date in technology? And keep in mind that the government is typically a little bit behind in terms of the latest technology. A lot of that is as a result of funding. And governments are typically risk averse. So they don't like to change unless something is really proven to be a change to something. So proficiency with public GIS. Being able to navigate map viewers can be frustrating because all of those different GUIs look a little bit different, but as you get more practice, it'll be better. So, but it can also give users an idea of how data is created, manipulated, and disseminated. And what that means is these different viewers give you some practice with the different tools, the different techniques, and some practice with the different kinds of data sets before you go off and create your own independent or individual project. So being proficient with public GIS basic navigation and tools helps prepare you for using a GIS, which is, again, related to the assignment this week, being able to use a public GIS to gather information. And the more practice that you have with map viewers and public GISs, the better you'll be in navigating your own GIS project with your own GIS software. Also important to mention that not all map viewers have analysis tools. And a good example to think of is Google Maps, that you really can't analyze much. You can analyze distance, you know, what's the distance between point A and point B. You can also do some basic area and perimeter calculations, but you really can't do more than that. So the ones that do give you analysis tools are closer to how a GIS works as compared to just a map viewer where you can't analyze or do stuff with that data. But map viewers still provide spatial data for consumption and oftentimes for download that you can use. Again, this section of the PowerPoint is a lot for your exploration. I'm not gonna do a lot of talking. I'm just kind of gonna go through each of these slides fairly quickly, but you'll notice that there are links. I want you to take a look at these sites to see what they look like, to see what kind of data they provide, and for you to have in your tool belt, like, hey, if I needed to find spatial data for something, where would I go? So one of the first examples, and probably a pretty standard go-to for your first round of looking, is Esri's Open Data Hub. I've mentioned Esri before. Esri ArcGIS is the leading proprietary GIS software, and what you'll learn in methods and applications if you go on with the courses in GIS. But Again, using an OpenGIS, a free GIS like QGIS, which we'll start it in a few weeks, you can still use data that's in other places. So it doesn't have to be data that's provided by QGIS. You can use data that's been prepared and made available to the public through other sources too. So I encourage you to look at Esri's Open Data Hub. And you can also, you can look at the data and you can download the data as well. You can also add your own data. So I think that's pretty cool. Another source is natural earth data. Lots of vector data sets and raster data sets. Gives you some examples of the different vector and raster data sets. Again, raster is typically associated, raster analysis is typically associated more with remote sensing. However, you may find that you're adding raster data, in particular satellite imagery or some sort of imagery as part of your base mapping. So you may not do a whole lot of analysis on it from a remote sensing standpoint, but you can do a little bit of raster stuff in a GIS. USGS's Earth Explorer, United States Geological Society. It includes data outside of the US, so I think that's one of the perks to this particular site. It has a friendly user interface, making it easy to access remote sensing data. There is also a bulk download application, and then I included a tutorial here if you wanted to spend a little bit of time with Earth Explorer. The Geospatial Data Gateway, also administered by USGS, and it provides access to a map library of over 100 high-resolution vector and raster layers in the Geospatial Data Warehouse. It allows you to browse, look, customize, review, and download. So again, another great source for you. Now moving on to NASA's Earth Observations. It focuses on 5 themes with over 50 global data sets, and they're mostly climate related, which makes sense for NASA, right? So a couple different examples of the type of formats and the type of data that you might find. I also have a link here for additional world climate data sources. I don't work a lot with climate data. It's not my area of expertise. But again, I'm making this available to you to squirrel around and see what kind of sources are out there. And if you wanted to spend a little bit more time perfecting your skills in these different sites, this is part of the talk on becoming familiar with different map viewers and different tools that are available to you for free. One that you probably know fairly well in addition to Google Maps is OpenStreetmap. It's open to the public, but it's also created by the public. And so, there's the little disclaimer, everything is crowdsourced. The accuracy varies based on the creator, just like Wikipedia. OpenStreetmap, you can actually a connection to OpenStreetmap comes with QGIS. So that is one of the cool little features of QGIS is that it has built-in OpenStreetmap. And then there will be an assignment where you can add Google Maps as well when you're using QGIS. Also important to note is that OpenStreetmap has the biggest inventory of buildings in the world. You can't find a whole lot of building data, particularly in GIS format. So having access to a building inventory is pretty good. More information, again, from NASA is the Socioeconomic Data and Applications Center. They show human interactions with the environment. So whereas in a previous data source, you were just able to look at information related to climate and precipitation and temperatures and toxins and things like this. This actually shows our interaction with the environment. So it adds a new layer there. You can select GIS thematic maps of socioeconomic data. That means you don't have to go to the census to find it. You don't have to download it from there. You can actually assemble it in the CDAC system here. OpenTopography, it provides a portal to high spatial resolution topographic data and tools. Their data map shows most available data is in the United States, but there's some data available for Europe, Asia, and Australia. So again, trying to give you some sources for what's outside of the United States if you're interested in exploring that. Not as up to date on technology is the UN's environmental program. So they have a lot of UN related data. Some of the examples or variables that the UN is interested in include freshwater, climate, and health. Again, kind of not necessarily a human interaction with the environment or something, but they are a repository. In my opinion, I feel like they're a little bit behind in terms of the technology that they're using to provide it publicly. That's just me being picky about it. It's a little clunky, but again, being able to figure it out, that's a skill that is learned through use. The IPUMS data, it provides census and survey data from around the world, integrated across time and space. So think back to those, the open geospatial data standards. Like this would be an application of those standards, is it's integrated across time and space, meaning you don't have to do that. The system does it for you as part of its preparation. A little history of the IPUMS data. It originally stood for Integrated Public Use Microdata Series, but in 2016, all of the project data took on the prefix as part of their project name. So they just changed the format of how it's available to you, but I just wanted to give you a little bit of history there. Terrapopulus, again, integrates census data from around or from over 160 countries. I think that's pretty significant. And it spans up to 6 decades for household level and aggregate data from more than 80 countries. Again, that's pretty significant. And that's a great source for information as it relates to basic land cover, land use, climate data, but also household level information. And the unique thing about it is how you can explore temporal and spatial changes. That means that you can look at different data to compare over time and space. So that's temporal, time, and spatial, space. And it's supported by the National Science Foundation and hosted at the University of Minnesota. US Census, that is one of our go-tos for information as it relates to people. These links here, census maps, census mapping files, and interactive maps, I encourage you to explore those. In particular, the census maps and the interactive maps. Note that the interactive maps requires Flash Player, so if you don't have Flash Player installed, you're going to get an error message on that. But the other ones, you don't need Flash Player. Census mapping files, clearly that's something that will be of value to you in the future. We're not necessarily going to use it for the class, but again, I'm making these sources available to you for more than just this class. Now getting a little bit more specific to our locality, Cuyahoga County OpenGIS data, they have 32 feature layers. Most of them are, land management and administration related, boundaries, zoning, land use, streets, addresses, water features, and they have their own map viewer. So you could take a look at that. Not only the open data, like where can I find open data about or in Cuyahoga County. Again, the limitation is that there's only 32 feature layers. So it's not like, hundreds of different data characteristics. It's only 32. But I mean, boundaries, zoning, land use, streets, addresses, water. Like those are some pretty baseline data that you would use in a lot of different projects. So they're usually the most popular that show up in their feature layers that you can access and download. And then Cleveland GIS. Your assignment is also related to or is using one of the Cleveland GIS viewers. Within Cleveland GIS, they have a few interactive map viewers. I'm going to say it's not organized very well. And I think it's a little too specific with some of the interactive map viewers that they have, but again, it's based on demand. What is the public asking for? What's the hot thing? And are we making that available for people to use for analysis? Also, you have access to the attributes of the data. So not only can you see the map, but you can see the data that is the characteristics of that data. So you have access to both the map view and the attributes. And the CAD call assignment is giving you some experience with doing interactive map analysis and also attribute analysis. So, and also I believe one of my graduates works for the Cleveland Planning Department, especially, or his specific task is managing the Cleveland GIS. So you might see somebody familiar if you know some of our grads out there. I think that is the last slide. So again, I want you to go through and take a look at all of these different data sources for nothing else than just to get some experience with all these different data sources. You know, how do they look? How do they operate? Are they easy? Are they difficult? Are they outdated? Are they, can I use the data? Is it relevant to me? Again, I kind of expand your horizons in terms of being able to access spatial data. I look forward to talking to you next time. I hope you have a great weekend and a great day, and I will be seeing you soon.